Our goal today is to use the law of detachment. And the law of syllogism. Okay. These two laws are going to allow us to learn about deductive reasoning. So they'll use the law of detachment and the law of syllogism. So the law of detachment is part of this deductive reasoning. What it says is if a conditional is true and its hypothesis is true, then its conclusion is true, which we talked about that. We talked about if a conditional statement is true and the hypothesis happens, that the conclusion must occur. So what that means is, in the symbolic form, we said if you have your hypothesis leads to your conclusion. So I'm going to color code these. So our hypothesis will be red and our conclusion will be green. If this conditional statement is true, then we can apply it to more specific things. So if we're talking about someone, and then that someone turns into a person. So if the conditional statement was something along the lines of, if you study hard, then you'll do well on your test, and then we apply it to a specific person. So we detach it from a generic phrase, a generic statement, and we can say, if Sally studies hard, then Sally will do well on her test. So we can apply it to a specific person or a certain event. So if you have this conditional statement, P implies Q, and that's true, and P occurs, and it's detached, it's not the generic statement, it's applied to something specific. So when P occurs, meaning it's true, so P is true, then Q is true to also that specific event. So P occurs and Q must follow. So we're going to do a couple examples of this law of detachment. The first example is if M is the midpoint of a segment, then it divides the segment into two congruent segments. M is a midpoint of AB. So now we're not just talking about a generic segment, we're talking specifically about the segment AB. So our conclusion, now we can only draw a conclusion. We can't draw a hypothesis. So if they give us the hypothesis that matches our hypothesis here, then that means we can draw the conclusion. So let's see if it matches the hypothesis. So M is the midpoint of a segment, and I'm given M is the midpoint of the segment AB. So see how that matches the hypothesis? That means we're going to conclude the conclusion. Sorry, I realized I made my hypothesis in red before. So now we can come up with the conclusion. The conclusion is going to be it divides the segment into two congruent segments. But instead of saying divides the segment, we're going to say that we're going to be more specific here. And we're going to say M is the midpoint of AB. It divides AB, segment AB, into two congruent segments. And that would be your conclusion, but it's more specific with that segment AB. Another way you could write this is you could kind of change the format. It would also work. You could say, then segment AM is congruent to segment MB, because you're showing that M is the midpoint, and if AB is divided, then it goes from A to M and then from M to B, and those are going to be two congruent segments. So you could just tell me what two segments are congruent. So either of these options, you could say it as a sentence like this, or you could specifically tell me what has become congruent. Either of those are options, but we're detaching it from this generic term, or from this generic statement, and we're giving it a specific meaning. All right, so the next one says, if a road is icy, then driving conditions are hazardous. So Fowlerville Road is icy. We have to make sure that it matches with the hypothesis. So our hypothesis is if a road is icy, and our conclusion is driving conditions are hazardous. We were given something similar to the hypothesis. The road is icy, but a specific road is icy. So since Fowlerville Road is icy and that does match our hypothesis, then we can make the conclusion. And the conclusion here is going to be that the driving conditions on Fowlerville Road are hazardous. Just because that matches with our conclusion. So that's what we're concluding. All right, so our next example, the hypothesis says if you give a mouse a cookie, and our conclusion is then they will ask for a glass of milk. So it says Emily the mouse asked for a glass of milk. They are giving you the conclusion. That matches the green, the conclusion. That means we can't come up with a conclusion. We were already given a conclusion. So in this case, you just write not possible. You can't do anything if you're already given the conclusion. So I'll write that here. You're given a conclusion. So you can't conclude if you've already been given a conclusion. All right, so that one's not possible. If you turn it over to the back side of the notes, we're going to talk about the law of syllogism. This is also very similar to the transitive property. Okay. It says that it allows you to state a conclusion from two conditional statements when the conclusion of one statement is the hypothesis of another statement. So the symbolic form says if we have P and it implies Q, and then you have Q happen and it implies R, and both are true, then what we can conclude that P goes directly to R. You don't have to go to that in-between Q part, because if P happens, then the green's going to have to happen, and if that's happening, R has to happen. So you can go directly from P to R. And we'll know that P to R is a true statement. So we're not going to ask you to go through and it'll give you two sentences. There are two if-then statements, two conditional statements. I'm not going to ask you to go through and determine if they are true or false. You're just going to assume them to be true, because then you'll see if you can come up with a new conditional statement, your conclusion from this. So I'm going to start with highlighting my hypothesis here. If you give a mouse a cookie, so that's my first hypothesis. My conclusion there is he will ask for a glass of milk. If you give a mouse milk, now since that's the same as the green before, I am going to highlight that also, because asking for a glass of milk, giving a glass of milk, we're going to pretend it's all the same. You guys are very familiar with this book, so I just wanted to show you those couple things. The new idea here says then he will ask for a straw. Okay. So what we get to conclude here is that if you give a mouse a cookie, then he will ask for a straw. So we go directly from the blue part of this, that blue statement, to the red conclusion, because you don't have to repeat that green in there. Okay, so when you have things that match, you can kind of think about them as it eliminates. So if you were to cross this off, then you have to create a sentence. So the greens, since you have two greens, they eliminate. Can you come up with an if-then statement with what's left? If you give a mouse a cookie, then he will ask for a straw, and it works. So that's kind of one way you can do it, is you can cross off the matching parts of your statement and see if you can make a conditional statement with what's left. This next one, the hypothesis says if a river is more than 4,000 miles long, our conclusion says it's longer than the Amazon. If a river is longer than an Amazon, now it's the same idea, so I'm going to stick with the same green color, then it's the longest river in the world. That's a new idea, so I'm going to underline this. Okay. Now again, since these are repeated, I'm going to cross them out and eliminate them. Okay. Can I come up with a conditional statement? I can. If a river is more than 4,000 miles long, then it is the longest river in the world. So I'm going to write that down. That's my conclusion. If a river is more than 4,000 miles long, then it is the longest river in the world. Okay, and that is actually a true one, because the Nile is more than 4,000 miles long, and that's the longest river. Okay, so going down. If you are late for school, I'm going to underline that in one color. Then you will get a tardy. New color. If you turn off your alarm, new idea, new color. Then you will be late for school. We had that idea before, it was blue. Then you will be late for school. Okay, so your matching ones get crossed off. We don't want to repeat. We'll see if we can come up with a conditional statement. Now, I'm not going to write my conditional as, then you will get a tardy if you turn off your alarm. Instead, you always start with the if part. So you do have to write these ones in reverse, but if you turn off your alarm, then you will get a tardy. So you can still come up with this, even though it was a little bit backwards, but that's okay. All right, so the next one. If we are on assembly schedule, that's the first idea. Then we have shorter classes. Even though they didn't write it as a then, we know that that would be how we would write it. If we are on assembly schedules, then we will have shorter classes. So that's a new idea. We'll use a new color. If we have a half day, okay, wait a minute. That's a new idea. If we have a half day, then we will have shorter classes. We had that. That was our red before, so we're going to do that in red again. Now, cross off what we have that's repeated. So the red was repeated, so I'm going to cross it off. Now we have to see if we can come up with an if-then statement. Our statement is, if we are on assembly schedule, if we have a half day. That does not make a conditional statement. That is not an if-then statement. So in this case, this one would be not possible. A hypothesis and conclusion didn't match. We didn't have an if part cross off and a then part cross off and left with an if and a then. We were left with two ifs, which do not make a conditional statement, so we cannot move on from that. That is the last of that. I do have a couple other videos as examples of the law of syllogism, so those will be linked also, that are great examples for you to watch.